Alright guys, even if there's a lot of wires and a mess, please follow me. So first you have the power supply. Second you have the signal generator. Third you have the amp meter. Don't just, take this one in consideration. After that you have a coil, flat pancake coil. Aiding mode, so basically it's power go inside the first coil, go back to the beginning of the second coil, and after that you get out. So the classic for producing radiant spike, so you go out, get inside a MOSFET that the gate is fed by the signal generator. After that, on the source, go back to negative of the power supply, and the good old diode to collecting the spike. So basically this spike go in, I don't want to call it my load, but let's call it my battery, or basically just a really small capacitor, high voltage in picofarad. I think it's like 10 picofarad or something like that, so it's really small. But what is nice by using that for analyzing the kind of output that I have is that on the voltmeter you get an instant reading of the voltage that is generated. So this way it's kind of a good way to know what kind of energy out that you get when you do your experiment. So let me start it and just try to go get like the highest voltage that I can, just with a single flat pancake coil aiding mode, by adjusting the frequency. Right now we will stay with the 10% duty cycle, and it's really just the frequency itself that I will change. So let me power it up. So now, right now we have, I don't know, maybe 75 milliamperes, and we reach approximately 458 volt. Let me try to tweak a bit frequency. So if I'm going a little bit higher, going down, if I'm going down on the frequency, okay, so I'm getting my peak almost 460 volts, and I'm getting my peak at 4 kilohertz, 4,100 kilohertz. Now, what happened if on the and also with approximately 80 milliamps. So now what happened if on the negative side of my load with right now the black wire? Usually the black wire goes straight to the negative of the power supply. But what happened if I decided to add, before going to the negative or the end of the circuit, the power supply? What happened if I put another flat pancake coil, same configuration, so aiding, so basically the beginning of the first wire of the first coil, at the end go back to the beginning of the second coil, and after that out. Basically I will show you what happened. You see the voltage, I'm touching nothing else than just adding it. There you go, guys. So now I'm at 900 something volts, and if you look, the power supply, even the power supply went down a bit because I'm aiding the current magnetic field generated from the input, and it's like if I'm aiding it, adding to it, or I'm not sure how I can call it, but basically I'm generating first approximately 460 volt, if I remember, and it's like if this second signal is added to the first signal, so you have like 2 times 460 60 450 volts, and this is what is the result for not for less input. Basically, the only thing, if you want to make it work, the only thing is that you need to be sure that you're really on the right polarity. What I mean by that is that right now, the way it's done, the north side is pushing up, and this one, the way it is, the north side also is pushing up this way. Because let me put it the other way. So you see right now it's just 450 volt. Okay, let me show you. So when I'm adding second coil on it, yes, I have this nice result. But let's say I'm flipping it upside down, and now I'm not aiding anymore the magnetic field. You see, it's the voltage go even lower, and I'm back at 80 milliamps. So here you go, guys. You have a nice way now to double your radiant output without affecting the input. And I think that this discovery, it's a pretty good one for everyone to know. So that's it.